All right, so Justin was asking about, so you're asking about if you have a linked list, how do you remove something? Okay. All right, so if we have a, come on. So if head points to an item in a list, and each item, right, points to another one. This one points to null. So if you know exactly which item you are going to remove, and you keep track of, the easiest way that I found was previous will point to the previous thing in the list that you, so basically you're going to search through this list probably, right, and find the lowest thing. And you'll keep a pointer that points to, you're going to keep several pointers. One, you're going to want to keep track of the current previous, right, and the current node. And then you have maybe one that is the biggest one so far, and the one that comes before the biggest one so far, right? Because you're going to, basically you're going to go through the whole list until you get to the end. And then you're going to decide, oh, I have some previous and some, let's say, max. Previous arrow next points to max. So what you'll end up doing is you'll set previous arrow next. Instead of, because it points to max, it will equal to max arrow next. All right, so that it, because this one points to, right, if the previous one pointed, was this item here, it pointed to this one, right? We want now this one to point to that other one's next. So now that has been removed from the list. Now you can either try and do it in one step, or you could iterate through the list, figure out which one is the biggest, then iterate through the list again to figure out which one is the previous to that one so that you can remove it from the list. And you're going to have a couple special cases, probably just one that's important, and that's if this is the first item in the list, then you need to change what head points to. So in this function, you need to pass in a pointer to a pointer, right, of head, of the actual full head of the list, right? So you want to pass a pointer to a pointer. So that way, if it happens that the biggest one is the first one in your list, then you need to be able to change that pointer at the beginning, right? So that's the only thing I think you would need to pass in, right? And either you can do that whole make a pointer to the pointer, right? Or you have your function return the pointer, but we're probably wanting to return the biggest item in the list, right? So that we can use it later on. So I would probably pass a pointer to the pointer because that would be easier than passing a pointer to some other thing. Other questions? Spencer says no.
How do you determine like when you want to make a root of two? Like this is only doing one thing. This is grabbing one of the smallest or whatever. Okay, but you need two of them to make a root node. How do you? Because like it's just gonna keep looping through this.
Well, so what I would do is what I made was a function to remove the smallest item from my list.
Okay.
So I call the remove from smallest, right? And one of the invariants or properties that I had was if I tried to remove something from the list and the list was empty, then I returned null. So I tried to remove something from the list, and I always know that there's at least one thing in my list. right? And then I go a second time and try to remove something in the list. And if I remove a second smallest thing, right, then I can have two things that I can merge into one. So I'll do that. But if that's null, that means I'm done, right? There's no other things in the list. So, right, if I have three things, right, I remove two, I put back one, now I have two things, I remove two, I still have two things, right, put back one, I remove one thing, I try and remove another, there are no things. Right, then I know that I'm done. So that's how I know that I need to exit that loop. Because every time it's going to get smaller by one when you're building the Huffman tree. Other questions? Ask now or learn new stuff. That's a threat and a promise. How are we doing? So how many of you have got like through the first part where you can print the frequencies? Okay. How many of those have got to actually building the Huffman tree? 1, 2. Okay, 1.5. Spencer's kind of shaky on that. Okay. That's due on the 9th. Right? So hopefully by next week, right, most of you should have part 2 done. Right? So that's the goal, right? If we do it one a week, right, you're going to be done in plenty of time. And that's what you want because it's probably harder than you might think. Or maybe not. Maybe it's not as hard as you might think. I don't know. Generally, it's usually harder than what you think. Right? Josh agrees. I've tortured him enough. Prepared him for it.
What's the hardest assignment you've ever assigned?
No. So the hardest assignments I've ever assigned are in the reverse engineering course when I was at Dakota State, because I like to torture my students. So there's one where they had to recreate source code, equivalent source code from what I created, so that one was pretty hard. But the final in that class was brutal. So I had 4 different problems, and if you did the first one, you would get a D on your final. If you did the 2 of them, you could get a C. If you did 3 of them, a B. And if you did all 4 of them, you could get an A.
Oh my god.
And the people who did all 4 of them, they said it took them like 20 hours. I gave them a week. But anyway, my reverse engineering course now is not that hard. Because you guys, they had a lot of C. And that was the ultimate course there. But so that was the hardest thing I ever gave somebody was that one.
What's the ultimate course here?
I don't know. I mean, this one's fairly difficult. I'd probably OS is the shell has a lot of stuff that it'll probably get easier as we go forward because students will have had C, but when you haven't had any C, like throwing kids in, making them write a shell is pretty time consuming. So, plus that class has a lot of reading and you got to give presentations. So, but I mean, I think that you guys learned a lot in OS. So, what? You think this class is harder than OS?
We're using pointers here. We're not really using pointers.
Oh, you had to use pointer. Yeah, here, the assignment is probably more detailed. But. All right. So today I talked about it, and we'll look at this a little bit. So C++ is the stepchild of C. Maybe it's like Cinderella. I don't know. I think it'd probably be more like the Ugly Sisters, but right, it's a stepchild of C that sort of adds objects. It came before Java. I think Java learned a lot from what they did right and did wrong in C++. And if you go back to object-oriented, there's scheme, which some people like more, some people like less. But one of the conventions that I'm going to show is the breaking out of different parts of a file into different files. Right? So C++ has the ability to have what we call header files. So a header file describes what something's going to do, and then we have the CPP file, which describes how we're going to do it. Right? So those two can be separate, and they a lot of times are separate. So this is a very simple example. So I have count.h, which is my header file. So you're going to see things that look similar to Java, right? But they are, in fact, slightly different, right? So we can have class, which says that we're defining a class. We give it a name, right? So that's kind of what's normal. But then when we talk about attributes and methods, right, we can group all of the private things together in one block, whereas in Java, right, you have to give public or private access to every single member. I don't know if that's a good thing or a bad thing. Probably it's a good thing where you can just mix public and private stuff and it's easier. All right, so we can see the keyword private with a colon, and then we list all the things that are private to that class. And then we can see things that are public. So in mine, I only made things public that were functions. So you can see the functions, right, because I have little parentheses around them, so that means they're functions. We have a type called void, which means nothing. Void, empty, nothing. Right, so we can say that we have a method that takes no parameters, it takes void parameters. We also have I have the same name as my class, and that is a constructor, right? Yeah, it's an object, it's a constructor. So you can see here that we've defined 3 methods. So we're going to have 3 methods that we need to define in our CPP file. So you see the pound include, right, or hashtag include if you guys are young, right? There's also this notion of using what are called namespaces. So namespaces is how you find variables, how you look up variables. If you ever do stuff in JavaScript, right, JavaScript has a global namespace, which is really terrible, right? Of all the things they did, that was probably the worst thing that they did. There might be others, like making it a loosely typed language, but right, so we can define different namespaces. In Java, we use packages in order to define namespaces. So when I define a method or a object called foo, right, I know that is, if you don't use the default package, right, it's going to be in, like, for example, for me, it'd be edu.unk.millermj. And then whatever my project is. Right, so reverse domain name type of things. And actually, you say reverse domain name. Domain names are actually a thing that's like completely backwards, right? Where they have like the most specific, and then they go, it should be like com dot whatever. But anyway, end of rant.
Does the reverse name, does that even really matter?
So in Java it does, because you break down packages based on, like, all the EDU packages should go together, right? But it's just a convention that people use in general. And it's, right, domains should be the other way, because then they would make a lot more sense, because you'd always know com, and then you'd know, like, Google, instead of, like, trying to read and figure out where is the last dot that comes before the com so that you don't get phished and stuff like that. But another item that we see is we'll see the name of the class that this belongs to with 2 colons. So that means that this is a class method, which means you have to have an object of the class in order to call it. Right? So it's like when you define a method inside of a Java class, right? Then you're allowed to call it on that object. And then how would we make a method where you don't have to have an instance of the class to call it? There's a super special word. How do I make a method that anybody can call? Public means anybody can call it. Or how do you make it so that any class can call it? You don't have to have an instance of the object. Static, right? So in Java they have static, and here we talk about, right, we use the class, right, a prefix, and then the 2 colons to mean that this is something that belongs to a class, or you have to have an object in order to call that. Okay? Questions? Not a lot different here. A little, not a lot. Okay. So here's a little bit more weird stuff, right? So we've seen common includes, right? And we can include IOStream. So IOStream is a method of doing input-output stream, right? We again include our count.h so that way we can know what counter is, what methods it has for it. Right, I call the constructor, right? So counter pointer C equals new, right? So we have the new keyword in here. And then we can see that there are these weird things called cout and cin, right? So cout is going to print something to standard out. Cin is going to read something from standard in. So I can say cin, and then you use the arrows, and the arrows you have to use the correct arrows with cin or with cout, right? So I always think of it as like you have the left-hand side of your page, cout, you're pointing to like I'm going to go out of my program, and then you're going to go in from the left-hand side. That's just how I think of it. Again, you should see things that you recognize from C and from Java, right? So you see the keyword new, right? So that tells us that we have a new object. It's actually doing malloc for that object. And basically, currently, right, what you see is if you say new, it's going to malloc the size of all of the data items that we have for that object, right? So for that object, we had 2 variables, right? So those are 2 integers, so it actually allocate 8 bytes for this object. Okay? So it's just like your structure, right? You do size of struct. Well, here it automatically calculates that. It's going to call the counter method, right? Initialize the variables as we saw. And then endl is new line, end of line. And really you can say std : cout, std : endl, or if you use, say, using namespace std, then I don't have to do any of that garbage, right? I can just use them directly. Questions on that?
Every time you use new, you're mallocating.
Yep. And then if you are done with something, right? So I didn't do this in here, but you would do delete. And that will free the memory that is allocated by that object.
So why are they making this one C all of a sudden?
What?
So why are they making this one C all of a sudden when they used to?
Well, so the point of learning C is that when you get into the computer organization class, we learn assembly, and there's a direct correlation with what we do inside of C with what we do inside of assembly. And so if you want to understand why is it that a Stack Overflow exists, you have to understand some C so that when you reverse engineer that and look at the assembly level, you can say, oh, I understand that every time I call this function, it pushes some data onto the stack. And if I keep pushing data onto the stack, eventually the stack hits the end, overwrites part of my heap. All of a sudden, I get a buffer overflow. Or, sorry, stack overflow. And then when we talk about buffer overflows, oh, well, I just allocated it like Spencer did, right? I just like dynamically put it in here. Why is that a bad thing? Well, stuff gets overwritten.
Spencer did it.
Spencer did it. It's all Spencer's fault. Right, so when we get into that computer organization class, we need to have this. Right, so when I came I decided, because the way we did it at Dakota State was we actually made students learn assembly, whereas it was seen several years ago that assembly wasn't something that was as useful for students, and now that security is actually something that the university and our department cares about, right, we actually need to learn these types of things. The other reason is that in order to get accreditation with the NSA for our cybersecurity program, we need to have low-level computer languages, so that includes C, and that includes assembly, and that includes reverse engineering. So,
Yeah, well, here's my real question.
okay.
Can I do this, teach us in C and 180?
Duly noted. So I know that John is going to be doing C for this class. I don't know if in 180 he will be doing that.
I'm just saying the subject we go over is just a bunch of random things in that class. So it'd be useful to just focus on this.
That is actually where I wanted to push this to start, would be in that class. But again, we just started this change actually this year. Like, this is the first semester, and John's on sabbatical, so I'm teaching it right now. But this is the first semester we're learning this.
So in the future, if this gets pushed to 180, what would this class entail?
So you would do more of the algorithms, right? So I knew that there was a learning curve associated with learning C in this class for all of the people who are not on operating systems. So, right, there would be more implementation of different things, like actually implementing a binary search tree that was a red-black tree. So that would be one assignment that I would probably do. Maybe a little bit more implementation of some of the other structures, like a normal binary search tree and then a red-black binary search tree. I think those are important ones to do. But C, I knew we wouldn't have time to do all of those and cover C, that's why.
So what you're telling me is that this class last year would have been a lot easier, but it's easier now than it would be next year.
Correct. All right. So we saw that, and then, right, so in order to compile this, right, we have to compile both count.cpp and main.cpp. And the compiler we use is the same but different, right? So instead of GCC, which is the GNU compiler collection, it's G++, which is the GNU C++ compiler. So to compile this, I'd say G++ count.cpp main. I know you guys all love typing stuff in, right, repeatedly over and over again. So I thought I would at least introduce what are called makefiles. So if you go out into the open source world in general and go find some project that some random dude made, and you're like, oh, I want to use that project that random dude made, and he made it in C or C++, he is going to have typically a type of system that's used to build the project. And they'll say, you need to type make, and then make all, right? And I want to at least show you guys how that works. So when you type make, it's a project that manages the building of a very large and complex system. We don't do super large projects. We don't do large projects really at all. But when you have a big one, right, it might take days or weeks to, or not weeks, days sometimes. I don't know how many of you like to torture yourself, but if you ever want to go and try and build a Gentoo system, because Gentoo has this notion that you should compile everything from source. And there's Gentoo level 0, where you compile your kernel, you compile your compiler from source, and then you compile your kernel, and then you compile every single library that you want to do, right? It's like self-torture, and you don't get that much speed out of it. So the way they do that is they have a file called makefile, no extension on the end of it. And basically in a makefile, you can define variables, like cc is our compiler. That's typically what's used for that. The flags are different flags that we want to add. So for our C program, we might say --std equals C99. Right here they're doing minus G, which is at debugging symbols. Minus wall, anybody know what that is? Probably not. It means with all errors. So it's going to tell you all possible errors and warnings that you can have. Right? You can say like with none or something and it'll like not tell you anything bad that happens, right? Pretend it's not there. All right, so typically there's a couple different sections, right? So all is, hey, I'd like to build all the things that are in this, right? All the properties. So a lot of times you'll say make all, and it'll build all the stuff. So all is going to say, I have a binary that I want to create, which is called main.out, and I have another binary called vector.out. Well, how do I build those? Hey, we got little definitions of them below. So if I want to build main.out, I require the file counts.o and main.cpp. Right? So those are two things that are required for that. So the nice thing about make is that if those files did not change, then it won't recompile them. And so it's going to save you compile time eventually. Right? So if you just edit one file and you have 1,000 files, it may only have to compile the 10 files that require that file in order to build the whole project, instead of compiling all of the files for it. So to do main.out, we need count.o. Well, if I don't have count.o, we can do this. So we've always sort of built the entire project all at once. But what happens is if you have a big project, you'll actually generate these .o files, and a .o file is an object file. So it's like a representation that the compiler can very easily understand and put into another binary version of a library. So you can do the $CC, which is G++, and then you get the flags, minus G, minus wall, and then do the just minus C flag, and that'll say just compile and create me a .o file for this. So that'll generate count.o, right? And it requires count.cpp and count.h. So if either of those change, then it'll recompile count.o. If they don't change, it's not going to recompile. And it does it really basically by just looking at the timestamps and say, does count.cpp have a newer timestamp than count.o? Yes? Okay, we need to recompile. So once it builds those, then we can build our main. So we build our main, we use the G++, we say minus G minus wall, we use the minus O, which is our output file, O for output. Maybe you were going to say that. Right, and then we give all of the required objects first. Right, so if I had 10 objects that are required for main, right, I give all of those, and then the last one is the one that's going to have the main in it. Okay? There's also weirdness in that the space between over here and the $CC has to be a tab. If it is not a tab, make will throw a hissy fit and like self-implode and delete your entire system, right? It just like hates you, right? So don't do. You have to put a tab in, otherwise it like doesn't work. And then usually at the bottom you put a clean. So clean is like remove all of the things that you did while building, so that we don't have to worry about this. So it's using RM, okay, so remove. And it's doing the star.out, star.o, and all of the backup, star tilde, which is all the backup files. Now, when I was at Dakota State, I had students typing these in manually. And I had one, she happened to be a girl, but she put a space in between the star and the .out, and it deleted all of her files. So you have to be very careful with that, right? It's like, I think some of my students have also done like the compile, like GCC, and they do the out as the actual source file. So it'll overwrite their source file with the executable. I think some of you in here may have done that, right? And they're like, oh, I deleted my file. Oh no. Yeah, that sucks. Right, so you need to make sure there's no space between the asterisk, right? Asterisk is anything, right? It doesn't match on anything. It's a regular expression, which we learned about in 402. So anything dot out. Okay? So to use this, we'll do make all. And so if you say make all, the program make will look for a file called makefile. Right? If you name it something else, like makefile.txt, you do like a -f to tell it which file to use. But by default, it looks for a file called makefile with no extension. Right? And everything's up to date. Well, if I want to get rid of all my stuff, make clean. You can see all we have is our normal files. Make all. Right? So I compiled count.cpp once, right? Even though I used it for 2 different executables that I made. Right? So I compiled that once. Compiled each one of these one time. Right? So compiled main.out and compiled one called vector.out. Right? If I type it again, right, it won't do anything, right? Because everything is up to date. All I have to do is say something like touch vector, and then it'll rebuild it, right? So touch just updates the timestamp. Timestamps are now, right, has a newer timestamp, recompiles. So, right, this is something that's good for if you got a lot of executables, right, and you want to build them, and you don't want to remember that stupid -std equals C99, right, -O, blah, 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 right, you get tired of typing it, you exit your terminal, and you forget it, right, so this will help you with that. Okay? So I'll show you one more thing, and then we'll be done for today. So, again, this makes me cringe, right? So, vector is just a list of things, right? It's an unordered list. So, C++ has a bunch of libraries called the standard template libraries, or STL. So in the STL, vector is one of them, right? So they also have, just like C++, or just like Java, they have maps that will do red black or binary search trees, or red black trees, or hashing, right? Array lists, things like that. So one of them is the vector. So here it's using std : right? So the regular namespace vector, you parameterize it, saying this vector can hold variables of type counter. Right, again, weird syntax, right? The parentheses say I'm going to create 5 of these objects, and for all of those objects, I'm going to call the constructor counter with the attributes 1, 3. And then line 10 is the atrocity of doing a for loop using an iterator that C++ has, right? This is awful, right? If you look at the new versions of Java with Lambda, right, this is a one-liner that makes way more sense. So, but again, I'm not a C++. Maybe there's an expert out there that says, oh, there's a better way to do it, but this is the way I used to have to do it, and it sucks, right? So you get an iterator that starts at the beginning. You check to make sure the iterator is not equal to the end. You do an increment, right, and then you can use that iterator within your loop, right, in order to print out something. So this is just printing off the get upload, which clearly is going to be the same for all of these, right? All of these objects are the same. So, if you need to do something in C++, and there are definite uses of C++ if you want to do object-oriented, and you want to run it at a very fast level, right? So, the difference between Java and C++ is significant, right? C++ is going to run much faster because it's actually generating an actual executable and running it, whereas Java runs a virtual machine that is an interpreter that runs it. Java does a pretty good job, but then you get to Python and does a way worse job, right? So I know that at the programming competition in Lincoln, they said, yeah, you can use C++ or Java or Python, but there are valid solutions in Python that will not finish in time because Python is so much slower than Java or C++. They actually said that the first year that they had Python as a programming language. Yeah, I mean, when you get into using arbitrary precision, right, that's going to take a long time in any language because, like, if you use a big integer, big decimal, I don't know what exactly you were doing. Just did you use the big integer class or? Yeah, you use big integer if you need to do like arbitrary precision large math, right? And then it slows down quite a bit because it has to chunk it up. I mean, even C or C++, if you have a number that's 9,000 bytes long, and you need to multiply it by 1 byte, right? You got to multiply every single one of those bytes, and then you got to add all the carries, and it's just.
I had one program we were using showing us that would do these problems and that.
Yeah, John likes Racket. I don't like Racket as much.
Would you rather use C++ or Perl?
That's like saying, would you rather get eaten by a lion or a bear? Neither one sounds good. I think I'd go with C++. I hate Perl. And then you're gonna look, well, which do you like worse, Perl or PHP? And again, I'd have to say Perl, but okay. So that was an example. Just thought I'd show you guys that. So we'll talk a little bit more. There's additional things like inheritance that we'll talk about. So C++ has a different inheritance model than Java. It has multiple inheritance. So like you can have like 17 parents, right? And you have to do all of them. And there's virtual methods, and so we'll talk about some of those.
Aren't
All right.
we supposed to talk about why we're not supposed to use searcher anymore? Use like
Stir in and
Yeah.
versus stir. Yeah, we'll talk about that too.
okay.
Again, that gets down to the like how do stacks work and stuff. So we'll briefly talk about that. Why we need those. Well, I'll show an example. I'll do a buffer overflow. That'll be fun.